Okay, I'm going to be going over another word problem here, so let's take a look at the word problem. An initial number of bacteria presented in a culture is 10,000. This number doubles every 30 minutes. Part A says write a function expressed by the number of bacteria in time. Okay, so because I'm doubling every 30 minutes, doubling means times 2. So times 2, times 2, times 2, times 2. So that means I'm going to be growing exponentially. And I can see that by my graph here. So if I know I'm growing exponentially, then I know my form of the equation is going to be y is equal to a times b to the x. Remember, a is our initial value. B is our multiplying factor, what we're multiplying each time. And then x is number of years or whatever, depending on the problem. So I have to figure out what my initial value is. So let me go back to the problem. An initial number of bacteria is 10,000. Okay, so I know that 10,000 is A. And B, what I'm multiplying by each time. Since the number is doubling, that means I'm multiplying by 2. So I'm going to have 2 to the x. Now let me figure out what y and x represent. So let's go back to that problem. It says, okay, x is going to be time. It says this number doubles every 30 minutes. This is the tricky part. Okay, so usually our x or our t here is in years. We've been used to that. Now, I think it's probably easiest in this case for our t value to be in hours. All right, so if we double every 30 minutes and my x is in hours, that means my function has to be y is equal to 10,000 times 2 to the 2t. And here's why. If t is in hours, that means if 1 hour has passed, I've doubled twice. If I double every 30 minutes, in 1 hour, 2 different 30 minutes have passed, because there's 60 minutes in an hour. So if 1 hour passes, I double twice, so that's why I have 2 times t. We did an example in class where we had our exponent was t over 2. And the reason why our exponent was t over 2 was because our t was every day, and we were doubling every other day. So since we only doubled every 2 days, we had to divide by 2. But in this case, we're doubling every 2 times every hour, since we double every 30 minutes. I hope I explained that so you understand it. Okay, so here is my equation. I'm going to say where t is in hours, just so we know, so we can clarify that every 30 minutes, 2 times an hour, we are going to double. So this was the answer to part A. Now let's go to part B. How long will it take to get the bacteria number to be this much? Okay, let's see. Let's get my zeros right. 1, 2, 3. 100,000. So I'm solving for t, which is my exponent, and my y value is going to be 100,000. So I'm going to have 100,000 is equal to 10,000 times 2 to the 2t. So I want to isolate my exponent here. So the first thing I'm going to do is I'm going to get rid of this 10,000. So I'm going to divide by 10,000. Now let's see how many zeros I can cancel. Cancel, 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 cancel. So I'm left with 10 divided by 1, which is just 10. And then here I have 2 to the 2t. I don't have anything else I can bring over without dealing with this exponent now. So I know the inverse operation of exponentials is logarithms. So I can take the log of both sides. So when I take the log of both sides, the whole point of taking the log of both sides is now to bring down my exponent so it's a regular number now. I just got rid of my exponent. So I have log 10 is equal to 2t log 2. Now the thing that I'm solving for here is t, the number of hours I have to wait. So I want to get rid of this 2, and I want to get rid of this log 2. Since this 2 is being multiplied by the t, and the log 2 is being multiplied by the t, the inverse operation is for me to divide by everything that I don't want. So I don't want this, and I don't want this. I have to do it to this side, so I divide by 2 log 2. So that means t is equal to log 10 over 2 log 2. Now, if I have a calculator, I can type this into the calculator. So I'm going to do that first. So let me pull up. I'm just going to log into, just going to type in online calculator. And when I type in online calculator, this lovely calculator for us pops up. So I have log 10 parenthesis divided by, in this case, it's dividing by 2, but it's also dividing by log 2. Since it's dividing by both of those, I need parentheses. So 2 times log 2, and then 2 parentheses there to close it, because that log 10 is being divided by all of that. Make sure you have parentheses there. Equals 1.66. So I'm talking about hours, right? I'm solving for t, I'm talking about hours. So this would round to 1.66 hours. We can just say that. Or like this is about 1.5 hours I'm gonna have to wait. So actually this, whatever this species is, little cells, they're cultivating super fast. Because to start with 10,000 and then to get to 100,000, that's kind of scary how fast it doubles. Okay, so this would give me 1.66 hours. If I wanted to change this,
Kayla Brush to the front office, please. Kayla Brush to the front office.
Come on, Kayla. All right. So now if I didn't have a calculator, this is like an invisible 1 here, right? So it would be like 1/2, because we have 1 over 2. So I'm pushing all the numbers to the side. And I'm going to have log, the little base is 2 because I'm dividing by log 2, 10. And 10 is a regular big number. And this is how I could express it in 1 log if I didn't have a calculator.